Hi, this is Professor Fernandez, and in this video, we're going to work out an example of evaluating trigonometric integrals. This comes from the notes from lesson 12 of this Calc 2 course. You'll find those notes on this website along with these other resources. So what do I mean first by trigonometric integrals? So this is a really great example of a trigonometric integral. It's an integral involving only sine and cosine functions, and they can be combined in various ways. Here they are appearing in as products of powers of sine and cosine. It could also be power of a non-unit argument trig function, right? So by non-unit argument, I mean this is not sine to the fourth x. It could also involve a combination of these things, right? It could be this integrand plus that one. So, lots of different ways that trig functions could appear. Some of the ways that they could appear we have treated in previous videos. So I'll send you back to, for example, video 21 and the rest of the ones in that lesson for integration by parts. Right? That may be something, an integration technique you will need to evaluate trigonometric integrals. Or maybe you need something a little simpler, like discussed in videos in lesson 20, something like use substitution. We'll use that in this video. Or maybe you just need, at the end of the day, we'll also use some basic integration facts. For example, that the antiderivative of cosine is sine x, right? So I'll send you to the videos in lesson 19, which review some of that. So let's talk about this example specifically and what to do to solve this integral. So first thing I'll mention is that in the lesson notes for this lesson, lesson 22, I have pretty explicit and detailed guidelines for how to handle the different cases of what could happen here specifically. What are those different cases? Well, there are really three of them. So one of them is the case we're in now, right? So in other words, I'm talking specifically when the integrand is a product of powers of sine and cosine with the same argument, right? This is x here, this is x. It's not like this is sine cubed of 4x and cosine to the 7th of 9x. When they have different arguments, you have to, that's a different part of the guidelines, right? That's also in the notes. But in the integrand we're in here, there are three things that could happen, right? The first one is that the powers here could add up to an odd number. That's the case we're in. So there's something you do there, right? There's a specific strategy, and I'll show you what that is in this video. If this 3 were a 2, then the powers would add up to an even number. There's something else you do there. Not the same thing I'm going to show you in this video, something else, but still covered in the guidelines. Okay, and then whether the going back to the odd case, whether the odd power is on sine or whether the odd power is on cosine, there is sort of a subtle distinction. It doesn't really amount to much, but that's kind of a third case. Okay. So I'm going to go over this as written and then show you what we can do to solve it. So the main idea behind the guidelines that are in the lesson notes for how to solve this is the idea that we know if we did a use substitution, u equals sine x, for example, and du equals cosine x dx. Actually, let me be consistent with what is in the lesson notes, and let's u be cosine x. Let u be cosine x and du the derivative minus sine x. If we did this, this term right here would become u to the fourth. So we'd be on our way to solving this. The problem is that the term that's left over is sine cubed x. I can't relate that to du, right? If I cubed the whole thing, I mean, what am I getting? Dx cubed? That's not a thing we've worked with in calculus. So the use substitution is a good idea to start off with, but it just doesn't work. It doesn't mean, however, that we abandon this route because it is sine and cosine. And, one is the derivative of the other, perhaps with a negative sign in the case of cosine. So what we want to do is we want to manipulate the integrand using trig identities to get it to the point where we can use this use substitution and have it work out. So how do I do that? Well, let's think, right? Du here was the only impediment to what I just did. This term here was u to the fourth. That was fine. So it was really about the sine x being cubed. So I want to somehow remove the cube from sine x and be left with just one factor of sine x. If I can accomplish that, then that would be the du. And if everything else in the integrand is only involving cosine x, then that will be a bunch of u's, u squared, u cubed, whatever. So that is our goal, to get the integrand to look like that. And to do that, the first thing I'm going to do is remind you of what this really means, right? Sine cubed x cosine to the fourth x really means sine of x cubed times cosine of x to the fourth. Okay, so that means that I have 3 multiplicative factors, right, of sine and 4 multiplicative factors of cosine. We decided we don't want to touch the cosine, so we'll leave that as cosine to the fourth x. And we decided that we would like to break this up so that it has 1 sine x in it. So you see, we can do that by breaking it up to just 1 sine x over here by itself. And then what's left over is 2 of these sine x, right? Because we have a original sine x to the third. So this is now sine x times sine squared x times cosine to the fourth x. This is the representation of the integrand that is really going to help us out in terms of successfully applying that use substitution. Okay, so let's do that. So I've now written the integrand in this form. So move this up a little bit here so we can work with it. Okay, and now therefore the integral is integral of this new integrand dx. Okay, and now let's carry out the use substitution, and you'll see it's going to work like right away. Actually, I lied. One thing we have to do, we haven't done what I said earlier to the fullest extent. There are still terms here that involve sine, right? So now we have to do one more thing, which is a crucial step. We have to convert these sines to cosines. How do I do that? Well, remember that sine squared x plus cosine squared x equals 1. That's our fundamental, base identity in trigonometry. So in this case, the term we want to replace is really just here. So if I move over the cosine squared, I get sine squared x equals 1 minus cosine squared x. And now everywhere I see a sine squared, I can replace it with that. This is the only place. So if I then put it in here, I have sine x times 1 minus cosine squared x, and then times the original cosine to the fourth x dx. Now we can go back and apply the use substitution, because now I've accomplished what I mentioned a few minutes earlier. We have a sine x dx, and then everything else in the integrand involves cosine x. So because u is cosine x, all these cosine terms and powers and whatever else they may be, right, products are going to be replaced by u or powers of u. So let's go ahead and do that. So remove some of the clutter again and move this up here. Great. So now to carry out the u substitution, if u is cosine x, then, well, this becomes u squared. Remember, cosine squared x is cosine of x squared. And also cosine to the fourth becomes u to the fourth, cosine of x to the fourth. And then the du, right, sine x dx, right, that gets replaced by, if I notice this -1 and I divide by it, I get minus du equals sine x dx. So sine x dx, which is here, gets replaced by negative du. So the integral becomes, let's take care of the u's first, 1 minus u squared times u to the fourth, and then sine x dx, that gets replaced by negative du, minus du. You can see that we have now accomplished what we set out to do, which is to use use substitution to convert this integral into an integral that we can actually do, right? This is in terms of u. And at this point, what we do is we're kind of back to Calc 1 methods here. I'm going to distribute the u to the fourth, minus u to the 4 plus 2, u to the 6, du. And then maybe I can do the integral from here, but if I multiply in the minus sign, it's u to the 6 minus u to the 4th du. And we can do this now using the integral version of the power rule. So I add 1, divide by the result. Over here, minus add 1, divide by the result. And then indefinite integral, so plus c. And then last step, we had used the u substitution cosine x for u. So everywhere I see a u, I replace it with cosine of x. And that gives me my final answer. So that is the result of integrating this using this method, right? And again, you can check this result by differentiating it and confirming that it yields eventually, after you'll have to do some trigonometric identities, plugging that in, simplification, checking that it yields this integrand. So you can definitely check that this is the correct answer. Great, thanks for watching.